Hi everyone. In this video we're going to be talking about two new rules, the distributive rule and the transposition rule. So we're going to get started with the distributive rule. The distributive rule says if you have P or Q and R, this is logically equivalent to P or Q and P or R. So one thing I want you to notice is that the main operator, I guess when it's undistributed, is right, whatever it is outside the parentheses, right, in this case an or, it goes from being outside the parentheses when it's undistributed to being inside the parentheses when it's distributed. And when it's distributed, the main operator, which is outside both parentheses, when it becomes undistributed, it goes from outside the parentheses to inside the parentheses. That's how distribution works. And it works this exact same way even if you change the operators. So if we had P and Q or R, we would get P and Q or P and R. And so again, the main operator when it's undistributed goes from outside the parentheses to inside both of the parentheses. And the main operator when it's distributed outside the parentheses goes from outside the parentheses to inside the parentheses when it becomes distributed again. So let's just take a look at it from the opposite direction, just to get a different look at it. So if you have Q or S and Q or R, this is equivalent to Q or S and R. So again, what's inside the parentheses goes outside the parentheses to become the main operator when it becomes undistributed, and the main operator when it's distributed goes from being outside the parentheses to being inside the parentheses. I also want to talk about another example that we're not going to be covering in these next the next exercises in the next video, because that video is hard enough as it is. But it's something that I think is important and that we should talk about. So let's say we have A or B and C or D, right? Now it doesn't look like we can do the distributive rule with this because there's no common disjunct here. But we actually can do the distributive here, and so this is how we do it. We would get A or B and C, or A or B and D. And again, in this example is a bit harder to place, but just think of A and B as one thing. Like if it was one letter, B and C, or B and D, right? Or I'll just call it X and C, which is like A or B and C, or, and then or goes outside, X and D, and A and B and D, and that goes outside. So in this way, we could kind of distribute it this way, and even though they don't have anything in common initially, we can still distribute it and get something different. And I assume the same thing would work with C or D. If we had C or D, we could get C or D and B, or C or D and A. So yeah, so it could work that way too. I'll just write it down. Well, let's say let me write it down here. Let's say we commuted it, right, to get C or D and B, and A or B, and we did this through just one commutative. From here we could get C or D and A. Let me put the brackets here. Or wait, C C or D and A, or C or D and B. So we could get different things by distributing it in this way. I might eventually add some of these problems, like probably no more than 2, to the exercise file. So I just thought I'd get it out there in advance if I eventually do. So now that I've explained how distributive works in some degree, let's take a look at the transposition rule. So transposition rule says if you have P, then, well, let me write it down. The transposition rule says if you have P then Q, then this is logically equivalent to not Q then not P. So in explaining this, I want to kind of copy this and just explain it this way, right? So if you have P then Q, and you have not Q, then you get not P, right? This would be, I'll write this in parentheses. This is how modus tollens works, right? If you have P then Q, and you have not Q, then you have not P, right? And in the second one, if you have P then Q, and you have P, then you have Q, right? That's how modus tollens works. So essentially, because these two are really inverses of one another, if you have one, you can get it and flip it and get the other. So if you have P then Q and you have not Q, then you have not P. That they're essentially just reversible for one another. And so that's how that rule of replacement works. One thing I want to mention is when we're talking about the commutative rule, I'll just do a reminder. When we were talking about the commutative rule, we had like A or B and C and D or something, right? And we mentioned that we can commute either of these and get, let's say, B or A and C and D. If we wanted to just commute inside the parentheses, or we could commute the conjunction of the main operator and get C and D and A or B, right, by commuting the conjuncts of the main operator. So we can do a bunch of different things. With transportation, we can also do this with parentheses, with conditionals in parentheses. So we could get P then Q and R then S, and we could we could use transposition on this to get not Q then not P and R then S, and we don't have to get rid of our parentheses to do this. So I just kind of wanted to throw that out there. So now that we've discussed both of these rules, let's take a look at some problems doing them. And we'll do that in the next video. See you then.